Hi everyone, in this video I will be discussing about polynomials. To start, we have here the definition of what is a polynomial. So in mathematics, a polynomial is an expression consisting of variables and coefficients that involve the operations of addition, subtraction, multiplication, and non-negative integer exponents. So let's take into consideration important parts of the definition. So we start with the word variables. So when we say variables, these are certain numbers in mathematics that takes different that's a different value. So for example, we have the x variable. So x is a variable since x can take again any value. So x can be equal to 0, it can be 1, it can be 2, it can be any number. Another example of a variable is y. So y is also a variable, and we also have z. So these are the most common variables that we usually use in mathematics or in algebra. Next, we have what we call as coefficients. So when we say coefficients, these are usually numerical coefficients. These are numbers that are placed before the variable. So if we have, let's say, 2x, so 2 there is our coefficient, or usually called as our numerical coefficient. If we have, let's say, negative 2y, so here, negative 2 is our coefficient or our numerical coefficient. So polynomials involve the operations of addition, subtraction, multiplication, also division, which I will be discussing later on. And take note, this is very important. The exponents, we've already discussed that one in our previous topics. So when we say exponents, these are the numbers wherein a certain number, a coefficient, or a variable is being raised to. So if we have x squared, we know that our exponent there is 2, right? So this is our exponent. The number that is it's the number that you raise a number to. So anyway, when talking about polynomials, the exponents should always be non-negative integer. So when we say integers, these are the whole numbers 0, 1 to positive infinity, negative 1 to negative infinity. But we take into consideration right now non-negative integers, meaning for polynomials, the integers should only be the whole numbers 1 up to positive infinity. So below we have an example, x squared minus 3x plus 6. As we can see, the exponent there is positive 2, which is a non-negative integer. So if you have a polynomial, let's say x to the power of negative 3, or if you have an expression x to the power of negative 3 plus 2x, that is not a polynomial because it does not satisfy the definition that it should have non-negative integer exponents, since negative 3 is a negative exponent. Also, if for example you have x to the power of negative 1/2, so our exponent there is negative 1/2, and negative 1/2, or even if we only have 1/2, is not an integer since it is a rational number. So therefore, it will not satisfy the definition for the polynomials that it should have non-negative integer exponents. Okay, so reminder, if we're talking about polynomials, the exponents should always be non-negative integers. So, history of notation. René Descartes popularized the use of letters from the beginning of the alphabet to denote constants, and letters from the end of the alphabet to denote variables. So, René Descartes is a famous mathematician, French mathematician. He was the one who discovered the Cartesian plane, and in algebra, in terms of polynomials, he popularized the use of letters from the beginning of the alphabet to denote constants. So, the letters A, B, and C. If you take a look at polynomials, or if you take a look at expressions in mathematics, the letters A, B, and C are usually used as constants in lieu or in replacement of numbers. And on the other hand, letters from the end of the alphabet denote variables. So as can be seen above, AX is the general formula for a polynomial in one variable, where the A denote the constant and X denotes the variable. So we can write AX plus BY plus C. So A, B, and C, those are our constants, or those are the numerical coefficients. X and Y, those are our variables. Descartes introduced the use of superscripts to denote exponents as well. So if we say superscripts, these are the exponents. These are the numbers placed above a certain variable or a certain constant. And again, in talking about polynomials, always remember that the exponents should be non-negative integer. Let's proceed. So we will be discussing this one further. There are actually different types of polynomials: monomial, binomial, and trinomial, but all of these are polynomials. These are just different types. Let's start with what we call as a monomial. So a monomial is a polynomial with just one term. By the way, what is a term? A term, it can be a constant, it can be a variable, or it can be a combination of a constant and a variable, or a coefficient and a variable. So for example, we have here 3x. So 3x is a monomial. It is only one term, okay? Another, we have 4xy. So that is also an example of a monomial. So as long as the coefficient and the variable are placed side by side, that can be considered as only one term. Okay, so next we have what we call as a binomial. So a binomial is a polynomial which is the sum or difference of two monomials. So the only time that there will be two terms or more is if they will be separated by the plus or the minus sign. So for example, we have 2x plus 5. 2x is one term. It is composed of a coefficient and a variable, and 5 is also a term since it is a constant by itself. And they are separated by the plus sign or addition. So therefore, those are two terms, or what we call as a binomial. Lastly, we have what we call as the trinomial. So a trinomial is a polynomial consisting of three terms or three monomials. So for example, we have 3x, that's one term, 5y, that's another term, 7z is another term, and the three terms are grouped together, or they are connected together by the plus sign or by addition. So again, trinomial because it has 3 terms. Now think of it this way, if you would like to picture it out. So a monomial, just like a monocycle which has one wheel. So if there is only one term, that's a monomial. Binomial can be compared to a bicycle. A bicycle has two wheels. So if you say binomial, there should be two terms. And trinomial, it can be compared to a tricycle, which has three wheels. So a trinomial has three terms. So that's how we can picture it visually. Let's proceed to uses or application. Polynomials appear in a wide variety of areas of mathematics and science. For example, they are used to form polynomial equations, which encode wide range of problems from elementary word problems to complicated problems in sciences. So, for those of you who are mathematics majors, polynomials are like a stepping stone, or these are very important, especially if you will be going further to advanced mathematics. They are used to define polynomial functions which appear in settings ranging from basic chemistry and physics to economics and social science. So, polynomials is not only applicable in mathematics, but you can also apply it in science, in chemistry, physics, economics, and other social sciences such as economics. They are used in calculus and numerical analysis to approximate other functions. At this point, let's talk about the degree. So what is the degree? The degree of a polynomial is the highest degree of its terms. The degree of a term is the sum of the exponents of the variables that appear in it. So if it's only a constant, like if you say you only have the number 1 or 2 or 3, the degree is 0. Okay. If the degree is 1, that is called a linear polynomial. If the degree is 2, that's quadratic. If the degree is 3, that's cubic. 4, it can be called biquadratic, or it's popularly known as quartic. So here's how you find the degree of a polynomial. Look at the following polynomials. Look at the yellow example. That's x squared minus 4x to the 4th plus x to the 6th power. So the degree of the polynomial is 6, of the whole polynomial, because the highest exponent is 6. But if we talk about the individual term, let's have x squared. So x squared, its degree is 2, since that is the exponent of the term. For the second term, negative 4x to the 4th power, the degree of the term itself is 4. And if we talk about the last term, x to the 6th power, its degree is 6. So that's the degree for each individual term. But if we take into consideration the whole polynomial, the degree is 6, because that's the highest degree among the other exponents. I hope that's clear. Next, let's look at the white example. That's x y to the 4th power plus x to the 4th y to the 4th plus 12. So if you have 2 or more variables, if you can still remember our topic regarding exponents, if like this one, x y to the 4th, what you will do is you will add the exponents in order to get the degree for each term. So for the first term, x y to the 4th, the degree is 5. Why 5? Because the degree of x is 1, the degree of y is 4. Of course, 4 plus 1 is 5. For the second term, that's x to the 4th, y to the 4th, the degree is 8. because you need to add the exponents 4 and 4. And lastly, since the last term is 12, and based on what I told you earlier, that if you only have a constant meaning these are numbers, 1, 2, 3, 4, 5, and so on, the degree is 0. Okay? So, if we talk about the whole polynomial, the degree of the whole polynomial is 8 because that's the highest degree or the highest exponent of the whole polynomial. We have here a table summarizing what I have previously discussed. So let's start with the first column. Given the polynomial 4, the degree is 0. Why 0? Because it's a constant. Again, always remember the degree of any constant is 0. Number of terms, there is only one term, which is 4. So if we talk about the type of polynomial based on the number of terms, that is a monomial because there is only one term. Second example, 3x plus 6, the degree is 1. Why 1? Because the exponent of x here is 1, and that's the highest degree since for 6 the degree is 0. So type based on degree, that's linear. We call it linear polynomial if the highest degree is 1. Number of terms, there are 2, that's 3x and 6. So in terms of the number of terms, that is a binomial because there are 2 terms. Third example, we have 3x squared plus 2x plus 1. The degree, the highest exponent of the whole polynomial is 2. And since the degree is 2, we call that one as a quadratic polynomial. Number of terms, there are 3 terms, 3x squared, 2x, and 1. So therefore, that is a trinomial. Fourth example, we have 2x cubed. The degree is 3 because that's the highest degree or the highest exponent. So talking about the degree, that is a cubic polynomial. There's only one term, it's only 2x cubed, so therefore that is a monomial. Last example, we have 6x to the 4th power plus 3x. The degree there is 4 because 4 is the highest exponent or the highest degree. That is a biquadratic or a quartic polynomial since again the degree is 4. There are 2 terms, 6x to the 4th and 3x, so therefore that is a binomial. Okay? For operations on polynomials, we have addition, subtraction, multiplication, and division. But in this video, I will be only focusing on addition and subtraction. There will be a separate video for multiplication and division. So addition of polynomials. Polynomials can be added using the associative law of addition, grouping all their terms together into a single sum, possibly following by reordering and combining of like terms. So for example, we have this method. We can line up the terms, then add the coefficient. Take note, we can only add terms if they are similar. So what do we mean by similar? You can only add a constant and a constant, and if there are variables, you can only add terms with the same variable or same variable and same exponents. So the first polynomial given, the first polynomial given is 3x plus 7. The second one is 2x plus 3. So if we will be lining up the terms, we should group together first all the constants. So that's 7 and 3. That gives us 10. We also have 3x and 2x. Those are similar terms. Why? Because they have the same variable. So we can add 3x and 2x. What do? We simply copy the variable x. What we only add are the coefficients, 3 and 2. That gives us 5x. Method number 2 is the more common method that we use. So method 1 is the vertical method. Method 2 is the horizontal method. So you group like terms, then add the coefficients. So given 4x squared plus 6x plus 7 plus 2x squared minus 9x plus 1, let's start with 4x squared. Looking for its similar term, it's 2x squared. Why? Because both terms have the same variable and the same exponents, therefore you can combine those terms. Next, we have 6x and negative 9x. Those are similar terms because they have the same variable. And lastly, combining the constants 7 and 1. So as a result, we have 6x squared by adding 4x squared and 2x squared. We have negative 3x squared by subtracting 6x by negative 9x. And lastly, adding the constant 7 and 1, that gives us 8. Take note that the sum of two polynomials is also, of course, a polynomial. Next, we have subtracting of polynomials. So before, you may have learned that subtraction means to add the opposite. So when you subtract a polynomial, change the signs of each of the terms to its opposite, then add the coefficients. We can still use the vertical method here. So line up like terms, change the sign of the second polynomial, then add. For example, given 4x minus 7 minus 2x plus 3. So arranging the terms, again, constant to constant, then similar terms. We change the sign of the second polynomial. So since that's positive 2x, we change that into negative 2x, and since it's positive 3, we change that into negative 3. So after changing the sign, we proceed to addition. So 4x plus negative 2x, or 4x minus 2x, is simply 2x. And negative 7 plus negative 3, since both are negative numbers, we simply add, then copy the sign, so that gives us negative 10. For method 2, or the horizontal method, so same with addition, we need to group like terms. So but before we do that though, we need still to change the sign of the second polynomial. So copy this one, the first polynomial, 5x squared minus 3x, so here. Then change the sign of the second polynomial. So negative 8x squared, we change that into positive 8x squared. And positive 11, we change that into negative 11. Then grouping the terms, 5x squared and 8x squared, because they have the same variable and exponent. Then simply copy 3x and 11 because they do not have any similar terms. So adding 5x squared and 8x squared, that gives us 13x squared, and just retain or copy 3x minus 11. So same with addition, the difference of two polynomials is also a polynomial. Now I have here question number 1. What is the simplified form of 2x minus 3x plus 2? So let's write that one down. 2x minus 3x plus 2. So we can actually combine 2x and negative 3xy because those are similar terms. They have the same variable. So what do we do again? We simply copy the variable and add or subtract the numerical coefficient. So 2 minus 3, that will give us negative 1. Or simply negative x, because in algebra we need not write 1 if it is a numerical coefficient or if it is an exponent. Then since 2 doesn't have any more similar terms, just simply copy positive 2. Therefore, the correct answer is letter A. Question number 2. What is the value of x when x plus 3 is equal to 10? So, in this equation, we can actually solve for x. So, let's write that down. X plus 3 is equal to 10. So, in solving for x, we can transpose 3 to the other side of the equation. Since it's positive, it will become negative. So, change the sign. Therefore, x is equal to 7. And the correct answer is letter A. Last question, question number 3. Solve 2x plus 4 is equal to 108. Let's write that down. 2x plus 4 is equal to 108. So, grouping the terms, we can combine or transpose 4 to the other side. That's 108 minus 4. It's negative 4 because again, if you move a term to the other side of the equation, change the sign. So that's 2x is equal to 108 minus 4. That's 104. Then dividing both sides of the equation by 2. Therefore, x is equal to 50. That is letter C. So that's the end of the presentation. If you have questions, clarifications, don't hesitate to comment on the comment section below. Or you can also ask your questions in our group chat, or you can also send me a private message in order for me to answer your queries. For your attendance, just simply comment your complete name, your course, section, or block number. That's it. Thank you so much, guys. You take care always. Bye for now.